Somewhere out there, right now, there's an animal a trained hunter could stare at from 10 feet away and never see. There's another that can feel your footstep from a mile off and vanish before you finish taking it. One of them reacts faster than the part of your brain that controls reacting. We like to tell ourselves that humans sit at the top, the species that hunts everything else. A handful of animals never got the message. They climb where we'd fall, disappear where we're already looking, and move faster than we can decide to move. After everything we've built, the rifles, the drones, the satellites, the patience, these are the animals that are still, somehow, almost impossible to hunt. Before we start, do me a favor. Drop a comment and tell me what time it is where you are right now, and what part of the world you're watching from. Siberian tiger. We'll start where it's cold. A Siberian tiger, Panthera tigris altaica, weighs about as much as 3 grown men, and in the forests it calls home, you will not see it coming. Not because it's far away, because it's already close. People who track these animals for a living have a phrase for the moment they realize a tiger has been watching them. They call it the feeling of being looked at. By then it's been there a while. This is the largest cat on Earth. A big male runs over 600 pounds and stretches more than 10 feet from nose to tail. It lives in the Russian Far East in a stretch of forest called the taiga, birch and pine and snow that sits chest deep for months. And here's the first thing that doesn't add up. An animal that size, painted in black stripes, dropped into a white landscape, should be the easiest target in the world. You'd think it would glow against the snow like a road sign. It does the opposite. The taiga in winter isn't bright. The light comes through the trees, gray and broken, sliced into 1,000 thin shadows by trunks and bare branches. And a tiger's stripes are built for exactly that. They don't hide the animal. They erase its shape. Your eye is looking for the outline of a cat, the back, the legs, the line of the body. The stripes cut that outline into pieces, and your brain, which survives by recognizing whole shapes, quietly decides there's nothing there. Hunters have described looking straight at a tiger and seeing a tangle of dead branches, right up until the branches stood up. Now the part that gets me. It's not just the camouflage, it's the silence. A 600-pound animal walking on frozen snow should sound like a man breaking through a crust of ice with every step. The tiger doesn't. Its paws spread under its weight like snowshoes, distributing the load so it doesn't punch through, and the pads are wrapped in thick fur that muffles the contact and keeps the tissue from freezing. So you get a predator the size of a refrigerator that leaves almost no sound and almost no shape. It can cover up to 40 miles in a day through that snow without its body temperature dropping, without slowing down, without making the noise that would give any normal animal away. And it needs all of that because of the math. A single Siberian tiger patrols a territory that can reach a few hundred square miles, in some cases approaching 1,000. One cat, an area bigger than some cities, walked and re-walked by a single animal that knows every ridge and every game trail in it. So the odds of a person finding one are already almost zero. The odds of finding one before it finds you are worse because this is its ground and you're the visitor making noise. Which leads to the thing the trackers talk about quietly. Across the Russian Far East, there are documented accounts of Siberian tigers that stopped being the hunted and started being the hunter. A tiger would come across human footprints in the snow, and instead of avoiding them, follow them, backward, tracing the trail to where it led, to the camp, and then waiting. Waiting for the moment the man with the rifle set it down. In one of the most studied cases, a tiger spent a long stretch of time methodically destroying everything that carried a particular man's scent before it ever went near the man himself. So you set out to hunt the largest cat on Earth, and the cat reads your tracks better than you read its. The roles don't just blur out there, they reverse. Great Po 2. The tiger hides by breaking up its shape. The next animal takes that idea and pushes it somewhere stranger. It doesn't break up its shape. It changes which species it appears to be. But before the ocean, stay on land and look at a tree branch. There's a bird in South America that people walk past every single day and file under broken branch. It's called the great potu, Nyctibius griseus, though the name it's earned across the continent is the ghost bird. During the day it picks the top of a broken stump, points its beak at the sky, closes its eyes and stops. Not slows down, stops. It can hold a single pose for hours. By some accounts, when the day is quiet and nothing's threatening it, the better part of a day, without moving a muscle. Its feathers are the exact gray-brown of weathered, rotting wood, and when it stretches its head back and freezes, the line of its body becomes a perfect continuation of the branch it's sitting on. People have stood directly under one, a foot away, and seen lumber. Here's the contradiction at the center of it. This bird has enormous eyes, huge, round yellow eyes built to catch insects in the dark. Open, they'd give it away instantly. 2 bright yellow circles on a branch is not a branch, so it closes them. And this is where it gets genuinely odd. The potu can keep watching you with its eyes shut. Its upper eyelids have small slits or notches in them, tiny gaps in the lid, and through those gaps it tracks the thing it's hiding from. It sees you decide whether that's a bird or a stump. It sees you give up. It watched the whole thing happen with its eyes closed, and it commits. You can walk up to the branch. You can put your hand on the branch. The bird stays frozen, betting everything on the disguise because the disguise has never failed it. Researchers who study them have noticed something even more deliberate. Over the course of a day, as the sun moves, the bird slowly adjusts the tilt of its body degree by degree, so that its own shadow keeps lining up with the shadows the real branches throw. It's not just shaped like the tree. It's managing its shadow to match the tree. A hunter calling, baiting, scanning the canopy for movement gets nothing. Because the target's entire strategy is to be the one thing in the forest that refuses to move. The potu wins by being mistaken for a piece of a tree. Malayan horned frog, on the forest floor. A few thousand miles away, there's an animal that wins by being mistaken for garbage. The Malayan horned frog, Megaphris nasuta, is a serious predator. It's wide, heavy for a frog, and it eats whatever fits in its mouth. Insects, small rodents, even other frogs. You would think an animal like that would be easy to spot. It is not, and the reason is that it has given up almost entirely on moving. It spends something like 99% of its life sitting completely still on the floor of a Southeast Asian rainforest, and its body is shaped fold for fold like a dead leaf. Not leaf-colored, leaf-shaped. It has ridges and flaps of skin that copy the veins running through a fallen, decomposing leaf down to fine detail. And above each eye and on its snout it grows sharp, pointed projections of skin, little horns, which is where the name comes from. Those horns do a specific job. The one shape a predator's eye is wired to find is the round eye of another animal, a circle looking back. The horned frog's projections cut straight across that circle and break it. So where a brain expects eye, animal, prey, it finds another jagged edge of leaf litter. The animal's whole anti-detection system is built around erasing the one feature that would give it away. It works almost too well. There are accounts of scientists who knew for a fact that a horned frog was sitting somewhere in a single square meter of leaves. They had it on record. They were standing right over it and spent hours on their hands and knees unable to find it. Hours over 1 square meter. The frog was right there the entire time, and the only thing that ever ended the search was the frog deciding to move. Some research even suggests the animal's coloring shifts subtly with the seasons, tracking how wet and how rotted the real leaves around it happen to be, so the fake leaf always matches the current batch of real ones. Pink fairy armadillo. The frog disappears by holding still. The last animal in this part disappears by doing the opposite, moving faster than you can react. There's an animal in Argentina that locals call the sand swimmer, and it has one of the best disappearing acts on the planet, which is part of why you've probably never seen one. It's the pink fairy armadillo, Chlamyphorus truncatus, the smallest armadillo in the world, about the size of your palm, wearing a pale pink shell and soft white fur. It looks frankly like a toy. It is built like heavy machinery. The fur and the shell are not decoration. This animal lives almost entirely underground in the dry plains of central Argentina, and when it feels a vibration through the soil, footsteps, a predator, anything coming, it doesn't run. It digs straight down. It can bury itself completely, gone from sight, in under 2 seconds, faster than you can reach for it. One moment there's a small pink animal on the sand, and then there is sand, and it has a tool for this that most people never hear about. The back end of its shell is flat, squared off, like someone sliced the rear of the armor clean across. As it tunnels forward, it uses that flat plate as a trowel, pressing and packing the loose dirt behind it, sealing the tunnel shut as it goes. So it isn't just escaping underground, it's bricking up the door on the way in. Anything trying to follow hits packed earth. This is an animal so committed to being underground, and so fast to vanish when it isn't, that it has slipped through the fingers of science almost completely. There are biologists who have spent their entire careers in Argentina, specifically in its range, specifically looking, who have never seen a single living pink fairy armadillo in the wild. Not one. They study it from the few that turn up and the tunnels it leaves behind. It's hard to hunt something. It's a different problem entirely when most of the people who've devoted their lives to finding it have never once managed to. Snow leopard. The armadillo escapes by going down. The next set of animals escapes by going up, into terrain where the ground itself does the hunter's job for him, and does it badly. Start with the cat nobody can find, in the place nobody can follow. The snow leopard, Panthera uncea, doesn't hide from you. It lets the mountain hide it. It lives in the high ranges of Central Asia, the Himalayas, the Altai, the Tian Shan, on cliffs and ledges at altitudes that climb past 18,000 feet, where the air holds little oxygen and a single wrong step ends in a fall that no animal survives. That's the whole defense. You don't have to outfight a snow leopard. You have to follow it across ground that kills careless things, and the snow leopard is never careless. Here's the number that should reset your sense of what this animal is. It can clear in a single jump a horizontal distance of around 50 feet. Stand 3 cars end to end and picture a cat crossing all 3 in one push, over a gorge, and landing on a rock the size of a dinner plate. It hunts by launching itself off cliff edges and dropping as much as 50 feet straight down onto prey, onto bare rock, and getting up without a cracked bone. The thing that should break it, the fall, is the thing it uses as a weapon. A blue sheep grazing on a ledge isn't watching the trail behind it. It's not built to watch the empty air above it. The snow leopard comes out of the empty air, and it does it without a sound, which is partly a choice and partly an accident of biology. This is one of the great cats, but it cannot roar. The other big cats, lions, tigers, jaguars, have a specialized band of cartilage in the throat that lets them produce that deep, carrying roar. The snow leopard's throat is built differently, and the result is that the largest predator on the mountain communicates in something closer to a chuff, a moan, a puff of breath. The animal that owns the highest hunting ground on the planet does it in near silence. There's no roar to track. There's no call across the valley telling you where it is. Now the part that turns the snow leopard from impressive into almost unfair. The tail. It's nearly as long as the cat's entire body, thick and heavily muscled, and it does 2 completely separate jobs. In the air, mid-leap, the cat swings it to steer, a counterweight and a rudder that lets a falling animal change its angle and stick a landing on terrain that offers no margin for error. That's how you survive jumping off a cliff for a living. And then at night, curled up in a wind that would kill most mammals, the snow leopard wraps that same tail around its own face and breathes through the fur, warming and filtering the freezing air before it reaches its lungs. Same organ, a flight control system by day, a breathing apparatus by night. The result of all this is that for a long time, people who study snow leopards genuinely could not find them. There are accounts of biologists working an area for years, convinced the local population was tiny or gone, who only later, going back through camera trap images and satellite collar data, realized the animals had been passing within a few meters of them the entire time, flattened against gray rock, watching the researchers look in the wrong direction. The ghost of the mountains earned the name honestly, not because it's rare in the places it lives, but because the mountain and the cat together make a thing you can stand next to and never see. Alpine ibex. The snow leopard uses the vertical world to disappear. The next animal uses it to do something that, the first time you watch it, your brain refuses to accept as real. There are photographs that get passed around every few years and dismissed as fakes. A near-vertical concrete dam in the Italian Alps, a wall that goes straight up and down, and goats standing on the face of it, just standing there, on the wall. The photographs are real. The goats are real. They're Alpine ibex, Capra ibex, and they are not supposed to be physically possible. An ibex is a big, heavy animal. A male can weigh well over 200 pounds and carries a pair of ridged, curving horns that can grow to nearly a meter. By every instinct we have about animals, something built like that should be lumbering and ground-bound. Instead, it has more vertical agility than the best rock climbers alive. And unlike them, it does it with no rope, no chalk, no gear, and no apparent concern. Ibex climb the faces of dams more than 100 feet tall, near vertical concrete, and they do it to lick the salt and minerals that leach out of the stone. They balance on outcrops narrower than a human finger. They go where a predator simply cannot follow, and they go there casually, the way you'd walk to the kitchen. The trick is in the hooves, and it's a genuinely elegant piece of engineering. Each hoof is split, and the two halves can spread apart to grip an edge from both sides. The outer rim of the hoof is hard as rock, sharp enough to catch and hold on a crack barely wider than a coin. But the center of the hoof, the pad, is soft and rubbery, and it works like the sole of a climbing shoe, deforming to press against the stone and grab. Hard edge to hook, soft center to stick. The animal is wearing a pair of climbing shoes that grew out of its legs, and the brain behind the hooves is doing constant, invisible math. Research on mountain goats and ibex suggests their sense of balance is wired to recompute the animal's center of gravity continuously, moment to moment, as it shifts weight across holds that would terrify anything else. The horns that look like dead weight aren't dead weight. They're a counterbalance, a tool for keeping the body centered over a foothold the size of a coin. Nothing about the ibex is accidental. The animal that looks least suited to a sheer cliff is the one that owns it. And a hunter at the bottom of that cliff looking up is looking at a wall he cannot climb at a target that has already decided the conversation is over. Nubian ibex. The alpine ibex hides behind cold rock and altitude. Its cousin to the south hides behind something a lot of people don't think of as a defense at all. Heat. 45 degrees Celsius. That's well over 100 Fahrenheit, and it's the kind of temperature where the rock itself becomes a barrier, where bare skin blisters on contact with stone and a boot sole softens and slides. That's the wall the Nubian ibex, Capra nubiana, chooses to stand on. It lives in the desert mountains of the Middle East and Northeast Africa, on steep faces of crumbling sun-baked rock. And it has turned the most hostile combination on land, vertical terrain plus killing heat, into a private fortress. It's a smaller, leaner animal than the alpine ibex, built for the furnace, and it climbs unstable desert cliffs at temperatures that would drop a person from heat stroke in the open. The hooves do the same trick, hard edge, soft grip, but the Nubian ibex adds a joint flexibility that lets the foot rotate and conform to the strange, broken angles of desert rock, surfaces that would read as a flat dead end to almost anything else. Those big arcing horns that look like a burden are doing the counterweight job again, stabilizing leaps across deep gaps in the cliff. They can come down a near vertical slope at speeds approaching 20 miles an hour, bouncing rock to rock controlled. On a face a human would have to rope down. Here's the detail that moves it from well-adapted into something that feels almost like strategy. Thermal studies from satellite data have found that the Nubian ibex deliberately spends the hottest hours of the day on the cliff faces most directly exposed to the sun. The faces that bake hardest. Not the shaded side, the blazing side. The reading is straightforward. Nothing else wants to be there. No predator, no person is going to push across superheated rock in the middle of the day to get to them. So the ibex parks itself in the one place the heat guarantees it'll be left alone, and waits out the afternoon in a furnace it can handle, and you can't. Harpy eagle. Up to this point, every animal in this part has gone up to escape, climbing away from the danger on the ground. The last one flips it. It doesn't climb away from anything. It lives at the top and it comes down. A harpy eagle, harpia, has talons longer than the claws of a grizzly bear. That's the fact to sit with first, because everything else follows from it. The rear talon on a big female can reach the size of a grizzly's claw. And unlike a bear, she drives those talons with a grip built for one purpose, which is to punch through a skull and not let go. The crushing force has been estimated at well over 100 pounds per square inch concentrated into points, enough to kill a monkey or a sloth on impact. Before the animal registers anything has happened. She's one of the most powerful birds of prey on Earth, and she rules the canopy of the Amazon, the roof of the rainforest. 100 feet and more above the ground, a world most predators never reach. That height is the defense. You cannot hunt what lives at the top of trees you can't climb, in a forest so dense you can't see the top. And the harpy doesn't make it easier. For a bird that size and a wingspan over 6 feet, she is almost silent in flight. Her wings are short and broad rather than long, built not for soaring over open country but for tight, controlled, quiet movement through the maze of branches. She can drop through gaps in the canopy without a sound and hit something on a lower branch that never knew the sky had opened above it, and she hunts partly by ear, using a feature most people associate with owls, not eagles. The feathers around her face can be raised and lowered to form a disc, a shallow dish that funnels sound toward her ears. With it, she can locate prey she cannot see, picking up the small mechanical noises of an animal moving in the leaves, a monkey chewing, the shift of a sloth's weight on a branch. She hears the meal before she sees it. The thing that ties it all together is the patience. Researchers who've put cameras in the tops of the Amazon's giant trees have watched harpies learn the daily routines of monkey troops, the routes they travel, the trees they favor, the times they pass through. The eagle uses that. She positions herself at the choke points along those routes, and she favors angles where the light works for her and against everything below, perching where the sun comes from behind her, so that anything looking up toward her is looking into the glare and sees nothing. Prey can't spot her. A hunter on the forest floor, 100 feet down, staring up through layer on layer of leaves into the same glare, has no chance at all. By the time anything in this forest learns where the harpy is already decided, and the only thing left to do is fall. Pronghorn. The harpy wins by being above you. The next 3 win by being gone before you've finished raising your arm. This is the part about speed, and speed turns out to mean a few very different things. Start with an animal that's running from something that doesn't exist anymore. The pronghorn, Antilocapra americana, is the fastest land animal in the Western Hemisphere, and the second fastest on Earth, behind only the cheetah. It can hit around 55 miles an hour in a sprint. But raw top speed isn't the strange part. The cheetah is faster in a flat-out dash. The strange part is what the pronghorn does next, which is keep going. A cheetah burns out in 20 or 30 seconds. Its body overheats and it has to stop. The pronghorn holds a brutal cruising speed of around 35 miles an hour for miles at a stretch. It doesn't sprint and quit. It sprints and sustains. Nothing in North America can stay with it. Not a wolf, not a coyote, not a person on foot, not a person on most horses. You cannot run it down because it does not get tired the way its pursuers get tired. And here's the question that haunted biologists for years. Why? Speed is expensive to build and expensive to maintain. Animals evolve exactly as much of it as they need to survive the things chasing them, and not a scrap more. So what is a pronghorn running from? Nothing alive on the continent comes close to catching it. The animal is wildly, absurdly overbuilt for its current world. It's like finding a small town where everyone can outrun a motorcycle and nobody can explain why. The answer is that it's running from ghosts. Tens of thousands of years ago, North America had its own cheetah, a fast, big cat now long extinct, along with other predators built for the chase. The pronghorn evolved alongside them, in a genuine arms race, each side pushing the other faster. Then the predators died out at the end of the last ice age. The pronghorn didn't. It kept the speed. So what you're looking at, when you watch one cross open grassland faster than anything can follow, is an animal still outrunning a hunter that vanished from the world before recorded history. It's overqualified for the present. The race it trained for ended ages ago and it never stopped running. The machinery to do this is extreme and it's mostly on the inside. The pronghorn's windpipe, lungs, and heart are oversized for its body, built to pull in and move enormous volumes of oxygen, the way you'd bolt an aircraft engine into a compact car. That's what lets it run hard for miles without choking on its own oxygen debt. And there's a quieter piece that's just as important. Studies of its gait suggest the structure of its legs and hooves absorbs the shock of each stride so efficiently that running fast costs it nearly the same energy as running slow. Most animals pay a steep price to go fast. The pronghorn found a way to make speed cheap. Put those together, the engine that won't run out of air and the legs that barely waste energy, and you get an animal that can simply leave. At a speed it can hold past the horizon for a predator that no longer exists. A modern hunter is just the latest pursuer to discover there's nothing to chase. There's only watching it get smaller. Kangaroo rat. The pronghorn is impossible to catch because it can run forever. The next animal is impossible to catch because of what happens in the first 38 thousandths of a second. 38 milliseconds. That's the number. That's how fast a kangaroo rat, Dipodomys, can begin its escape from a strike. For comparison, it takes the human brain somewhere around 200 milliseconds just to react to something it sees, to register the flash and start to move. The kangaroo rat is already airborne in less than a fifth of that time. By the time your nervous system has acknowledged that something happened, this animal has finished its response and is somewhere else entirely. It's a small desert rodent, North American, palm-sized, with long hind legs and a long tail, and it lives in some of the driest country on the continent. The reason it needs reflexes from another dimension is that it shares that country with one of the most efficient ambush predators on Earth, the rattlesnake. A rattlesnake strike is one of the fastest movements in the animal world. The snake covers the distance to its target in a fraction of a second, faster than you can flinch. Against most prey, it's over before it starts. Against the kangaroo rat, the strike misses over and over, and for a long time nobody understood how. High-speed cameras finally caught it, and the footage is hard to believe even when you're watching it. The snake launches, and in the sliver of time between the strike leaving and the strike arriving, the kangaroo rat jumps. Straight up, sometimes several times its own body height, clearing the snake's open mouth completely. Some of them go further than just dodging. As they leap, they kick. They drive their powerful hind feet into the snake in midair, a move researchers have flatly described as a ninja kick, shoving the predator away and using that same shove to fling themselves out of range. It's not just avoiding the attack. It's countering it, in midair, in a window of time too short for a human to perceive at all. What makes the reflex possible is the animal's hearing, and the hardware is genuinely strange to look at. The kangaroo rat has hugely inflated chambers in its skull called auditory bulli. The bony structures around the inner ear blown up like balloons until they take up a large share of the head. They turn the skull into a resonating chamber tuned to low, faint sounds. The soft hiss of a snake sliding over sand, the slicing of air ahead of an owl's strike. It can hear the attack beginning before the attack lands, and that head start is the whole game. And there's a final detail that has nothing to do with escape and everything to do with how hard this animal is to corner. The kangaroo rat can live its entire life without drinking a single drop of liquid water. None. It pulls all the moisture it needs from the dry seeds it eats. And its body is so miserly with water that it barely wastes any. So you can't even wait it out at a water source, the oldest trick there is, because it never goes to one. It doesn't need to come to you, and when you come to it, it's gone in 38 milliseconds. There's no angle. Jerboa, the kangaroo rat escapes by reacting faster than you can perceive. The last animal in this part takes unpredictability and pushes it all the way to its limit, to the point where being faster wouldn't help you. Because not even the animal knows what it's about to do. The jerboa, family Dipodidae, looks like it was assembled from spare parts that don't belong together. It's a tiny desert rodent of Asia and North Africa with comically long hind legs, like a miniature kangaroo, and front arms so short they look like a manufacturing error. It has a long tail for balance and oversized ears on some species. The first impression is that something went wrong in the design. The second impression, once it moves, is that nothing went wrong at all. A jerboa can launch itself nearly 10 feet in a single bound. For an animal a few inches long, that's a jump of more than 20 times its own body length. Those ridiculous hind legs are the reason. They work like loaded springs, storing energy and releasing it all at once, firing the animal off the ground with no wind-up, no crouch, no warning. One instant it's on the sand, the next it's 3 meters away. There's no tell. No gathering of the body that a predator could read in time. But distance isn't what makes the jerboa impossible. Direction is. When a jerboa flees, it doesn't run in a line. It doesn't even run in a predictable curve. It bounces, and every bounce changes direction sharply in midair, with no pattern a pursuer could lock onto. Left, then a hard cut, then up, then somewhere that makes no sense. Anything chasing it has to commit its own body to a direction a fraction of a second before it lands. And by the time it lands, the jerboa has already changed the answer. Here's the part that's genuinely remarkable, and it comes out of researchers who model how animals evade predators. The jerboa's escape path isn't just hard to predict. As far as the math can tell, it's random. Truly random, what scientists call stochastic. The animal isn't running a clever pattern that a smart enough predator could eventually crack. There's no pattern to crack. And the strangest reading of the data is this. The jerboa's own brain doesn't seem to choose the direction of the next jump until the instant its feet touch the ground. It's not planning ahead. It can't be outthought, because it isn't thinking it through in the first place. It decides at the last possible millisecond, which means nothing watching it can decide any sooner. Sit with what that does to a hunter. Every targeting system ever built, from a hawk's eye to a guided missile to a person leading a moving shot, works by predicting where the target will be. You don't aim where it is, you aim where it's going. The jerboa's entire defense is that where it's going is information that does not exist yet. Not in the hunter's head, not in the jerboa's. You can't lead a shot on a number that hasn't been generated. So the fastest reflexes in the world don't help you here, and neither does patience, and neither does a better algorithm. You're trying to predict a coin that hasn't been flipped, thrown by an animal that flips it on the way down. Canada Lynx. The jerboa can't be hunted because you can't predict it. The next three can't be hunted because they predict you. They know you're there long before you know about them. And with two of them, finding out is the last thing you'd want. Start in the deep snow with an animal that's listening to you from a mile away. The Canada lynx, Lynx canadensis. Here's the world the way the rest of us see it. It lives in the dense boreal forest across the north of the continent. Thick spruce, deep snow, low light, the kind of woods where you can't see 20 feet in any direction. Sight doesn't get you far in there, so the lynx barely relies on it. It has turned hearing into something closer to radar, and the result is that it knows a person is coming while that person is still the better part of a mile off, with no idea the lynx exists. The hunt is over before the hunter has any reason to think it started, because by then the lynx is already gone. Look at the ears, because they're not decoration. A lynx has long black tufts of hair rising off the tips of its ears, and for a long time people assumed they were just a nice bit of styling. Their equipment. The tufts appear to work like antennas, helping funnel and sharpen incoming sound, fine-tuning the animal's already extreme hearing. With them, a lynx can pick up the snap of a dry twig from well over a mile away inside a closed forest, where sound is swallowed by trees and snow. And it's not just sensitive, it's selective. Bioacoustic studies suggest the lynx can isolate the specific frequency of footsteps crunching through snow and lock onto it, filtering out the wind, the creak of branches, the constant low noise of a living forest, so that the one sound that matters comes through clean. It's not just hearing more. It's hearing exactly the right thing and ignoring everything else. And then there are the feet, which solve the other half of the problem. Moving through the same deep snow without making any of the noise it's so good at detecting in others. A lynx's paws are enormous, almost comically out of scale with its slim body, and they spread wide to work like a pair of built-in snowshoes. The math on them is striking. A lynx puts roughly a quarter of the ground pressure of a comparable cat, light enough to run across the top of powder soft enough to swallow a person to the waist. So you have an animal that can hear you coming from a mile off, and then leave across snow that you'd flounder through in near silence, on feet built not to break the surface. It's a perfect mismatch. You're loud, slow, and sinking. It's silent, fast, and floating. Long before you find the lynx has heard you, judged you, and decided you're not worth the trouble of meeting. Komodo dragon. The lynx detects you by sound. The next animal detects you by smell. And the difference is that the lynx wants to avoid you, and this one is deciding whether to wait for you. There's a reptile that can smell a single drop of blood from about 6 miles away, and it has spent millions of years using that to win. It's the Komodo dragon, Varanus komodoensis, the largest lizard on Earth, found on a handful of isolated Indonesian islands and almost nowhere else. A big one runs over 10 feet and weighs as much as a person and a half. At a glance it reads as slow, ancient, sun-stunned, a leftover, basically a small dinosaur lying in the dirt. That red is a mistake, and on its islands it's a fatal one. The Komodo dragon is one of the most efficient hunters alive, and it gets there by knowing where everything is, all the time, by scent. The tool is its tongue, and the system behind it is genuinely alien. The dragon flicks out its long forked tongue and collects particles drifting in the air, then pulls the tongue back and presses the two tips into a structure on the roof of its mouth called the Jacobson's organ. Because the tongue is forked, two tips, sampling two slightly different points in space, the dragon gets a stereo reading of a smell, the way two ears give you a stereo reading of a sound. It can tell not just that something is out there, but which direction and roughly how far. It smells in 3 dimensions. It can follow the scent of carrion, or of a wounded animal, or of a person across miles of island, and triangulate its way to the exact spot. And while it does, it's setting up. Komodos hunt by ambush, lying in the tall grass along the paths their prey uses. And that slow reptile can move in a short, shocking burst, fast enough to run down a person caught flat-footed at close range. It barely needs to, though, because of how it kills. For years, people thought the dragon's bite worked through filthy, bacteria-laden saliva that infected the wound. The real answer turned out to be worse and more elegant. The Komodo dragon has venom glands. Its bite delivers toxins that prevent blood from clotting and drop the victim's blood pressure, so the prey doesn't have to be overpowered or even held. A single slashing bite is enough. The animal walks away, often seeming fine, and then bleeds and weakens over hours or days. And the dragon, which has been smelling it the entire time, simply follows the scent of its decline and arrives at the end. And the bite itself is built like a weapon. CT scans have shown the dragon's serrated teeth are reinforced with iron along the cutting edges, capped in metal like surgical blades that don't go dull. So the thing that looks like a fossil sunning itself is actually a tracking system, a venom delivery system, and a set of metal-edged knives, all of which have known you were on the island since before you saw the coast. Inland taipan, the lynx avoids you. The Komodo waits for you. The last animal in this part does neither. It just sits there being the single most dangerous mistake you could make. And the cruel joke is that it would rather you never met at all. A bite from one snake can hold enough venom to kill around 100 grown adults. The same single bite, by the measures used in the lab, could kill something like 250,000 mice. That is the inland taipan, Oxyuranus microlepidotus, and drop for drop, it has the most toxic venom of any snake on Earth. There is no animal on land whose bite is, by that measure, more lethal. It lives in the cracked clay floodplains of Central Australia, in some of the emptiest, driest country on the continent, and the math of hunting, it is simple and ugly. The downside is not that you fail to catch it. The downside is that you do catch it, badly. But here's the contradiction that defines this animal, and it's a real one. The most venomous snake in the world is also one of the shyest, most reclusive snakes you'll ever fail to see. The inland taipan wants nothing to do with anything large. It spends its time down in the deep soil cracks of the floodplain, hunting rats in the dark, and its entire instinct on encountering something big is to disappear back into the earth. It is not aggressive. It is not lurking with intent. It is carrying the most lethal chemical weapon in the animal kingdom and using it almost exclusively on small rodents, while doing everything in its power to avoid the confrontation people imagine. The danger isn't malice. It's the consequence of crowding something that just wanted to be left in its crack in the ground. What's in the venom is the part that earns the reputation. It's not one poison. It's a coordinated attack. There are neurotoxins, and the especially nasty ones act before the body even raises an alarm. They block the signal from nerve to muscle at the source, so the system that's supposed to warn you something is wrong is one of the first things to go quiet. The venom also attacks the blood's ability to clot properly, and it carries an enzyme called hyaluronidase, which does something almost engineering-minded. It breaks down the barriers between cells, so all the rest of the venom spreads through the body faster. It's a poison with a delivery accelerant built in. The toxins don't just arrive. They arrive everywhere quickly, and they switch off the warning system on the way. So you have an animal whose defense is total. Not speed, not camouflage, not terrain. Just a flat, absolute no written into its chemistry. There's no clever way to engage it that improves your odds, because the thing you'd be engaging is the most efficient venom on the planet, attached to a snake that genuinely, sincerely would have preferred to slip away into the clay and never be found. The deadliest serpent alive is, by temperament, a recluse. It's only a roulette wheel because somebody insisted on spinning it. Needlefish. The taipan makes the ground dangerous to share. The next three move the whole problem into water, and water, it turns out, protects its own in three completely different ways. One of them protects itself by turning into a weapon and firing itself at you. Start there, at the surface, with the fish that fights back through the air. In parts of the tropics, more people are seriously hurt by a long, thin, harmless-looking fish than by small sharks. The fish is the needlefish. family Belonidae, and it does its damage by leaving the water entirely. It's a slim, silvery animal that lies near the surface, with a long beak-like jaw full of small, sharp teeth, the kind of fish that looks like it couldn't hurt anything bigger than a minnow. Then a light hits the water at night, or a boat comes through or something spooks it. And the needlefish does the thing that has put fishermen in hospitals and worse. It launches itself out of the water in a straight, rigid line, traveling at speeds that have been clocked around 40 miles an hour, and it doesn't steer around what's in the way. That's the part that turns it from a fish into a problem. A needlefish in flight is essentially a living spear. Its body locks straight, its jaws make a hard point, and the muscle in its tail fires it across the surface like an arrow off a bowstring, and it's drawn toward light, which at night means it's drawn toward the lamps on boats, toward the people holding them. It doesn't aim. It doesn't have to. A rigid object the length of your forearm crossing open air at highway speed will do damage wherever it lands. And where it lands is often a person sitting in a small boat at night trying to fish. Naval and trauma medicine has the case reports, and they read less like fishing accidents than like medieval combat. Needlefish beaks have punched through ribs. They've pierced through to arteries. There are documented cases of the rigid jaw driving into a skull or a chest cavity, behaving exactly like a crossbow bolt, a slim shaft of bone moving fast enough to penetrate deep into a human body. So consider what that means for hunting it. Most dangerous animals are dangerous when you corner them, when you crowd them, when you make a mistake up close. The needlefish becomes most dangerous in the act of fleeing. The light you're using to find it is the thing that triggers the launch, and the launch comes straight back down the beam at the source. It's the only animal on this whole list where the act of looking for it at night is, by itself, the thing most likely to put it through you. It doesn't defend a territory, and it doesn't fight for its life in your hands. It just turns into an arrow and goes, and whatever's in the line gets hit. A leatherback turtle. The needlefish protects itself at the surface by becoming a weapon. The next animal protects itself by going to a place where you simply cannot follow. Straight down, into the crushing dark. A leatherback turtle, Dermocles coriacea, can dive to depths approaching 4,000 feet and stay under for more than an hour and a half on a single breath. Put that in human terms. The deepest a person can go in scuba gear is a tiny fraction of that, and going much past a few hundred feet is a death sentence without exotic equipment and gas mixtures. The pressure at the leatherback's deepest dives would crush a human chest and force gas into the blood in ways the body can't survive. This is the largest turtle on the planet. It can reach the size of a small car and weigh as much as a grand piano. And it spends its life crossing open ocean and dropping into a part of it that no hunter can reach. You can't pursue what lives below the depth where you'd die. Here's the detail that makes the leatherback genuinely strange, and it's the opposite of what you'd guess. It doesn't survive that pressure by being armored. It survives by being soft. Every other big turtle you can picture has a hard, bony shell, a rigid box. The leatherback gave that up. Its shell isn't bone plate. It's a layer of tough, leathery skin over cartilage and connective tissue, flexible, almost rubbery, ridged like the hull of an old boat. And that softness is exactly what saves it. A rigid air-filled box would be crushed or would trap gas at depth in ways that kill. The leatherback's flexible body compresses as it descends. Its lungs are built to collapse on purpose, squeezing the air out so that no gas stays in the system to be forced into the blood under pressure. The thing that would seem like a weakness, a turtle without proper armor, is the precise feature that lets it go where armored turtles never could. It doesn't resist the deep ocean. It folds up and joins it, and it uses the ocean itself to travel in ways that make it nearly impossible to track or intercept. Satellite tags have shown leatherbacks riding deep ocean currents like express highways, crossing entire oceans, covering thousands of miles. They can travel for long stretches without the predictable surface routine you'd use to find a sea creature, using the deep, cold rivers of the ocean to move through a part of the sea most of us never think about as having geography at all. So even at the surface, where it has to come up to breathe, it's a moving target on a route written by currents miles down. And the moment anything pressures it, the route it takes is the one direction the entire history of human technology has struggled to follow. Straight down, into the dark, where it can stay long enough to be somewhere else entirely by the time it returns. White-throated dipper, the leatherback escapes by diving deeper than you can go. The last animal in this part does something that, on paper, a creature like it should not be able to do at all. It walks on the bottom of a river. There's a small songbird in Europe that, when something comes for it, doesn't fly away and doesn't hide in a bush. It walks into a fast, cold, churning river and keeps walking, along the bottom, underwater, against the current. It's the white-throated dipper, sinkless, a plump, round, unremarkable-looking bird about the size of a fist, and it has quietly broken several of the rules we assume apply to birds. It hunts, and it escapes in rushing water that would sweep a person off their feet. In the one place a predator chasing a small bird would never think to look, under the surface of a violent stream. What it's doing down there isn't really walking, and that's the first surprise. The dipper uses its wings underwater. It opens them and beats them to drive itself down and forward, effectively flying through the water, pushing against currents strong enough to roll stones along the riverbed, while it grips the bottom with sharp claws and pries loose insects and larvae. It doesn't have webbed feet. It isn't built like a duck or any of the birds we associate with water. It's a perching songbird, the kind you'd expect to see on a fence, and it has decided that the safest room in the house is the bottom of a freezing torrent. The body has quiet modifications that make it possible, and they're the kind you'd never notice from the outside. Its blood carries an unusually high concentration of hemoglobin for a bird its size, which means it can store more oxygen and stay down longer than a small bird has any business doing. It has a transparent third eyelid, a nictitating membrane, that it can draw across each eye like a built-in pair of swimming goggles, letting it see in murky, churning water. And research into its physiology suggests it can deliberately slow its own heart rate when it enters the cold water, throttling down to conserve oxygen and energy on each dive. None of this is visible when you look at it. It's a drab little bird bobbing on a rock, and then a hawk stoops, or a person gets close, and instead of taking to the air where it could be chased, it steps off the rock and vanishes downward into white water, to a place with no aerial predators, no land predators, and a current that erases the trail the instant it's made. There's nothing to follow it into. The river closes over it, and as far as anything hunting it is concerned, the bird is simply gone. Mimic octopus, the dipper escapes into water. The last three animals don't escape into anything. They escape into deception. Two of them lie to your eyes and ears so well that you never locate them in the first place. And the third doesn't trick you at all. It just makes sure you are never close enough to need tricking. Start on the seafloor with an animal that doesn't hide behind things. It hides behind other animals. Most camouflaged animals try to look like the background: a rock, a patch of sand, a piece of coral. The mimic octopus, Thomoctopus mimicus, does something stranger, and when you watch it, almost unsettling. It impersonates other animals. It's a slender octopus from the shallow, muddy seafloors of Southeast Asia, and it can transform its body, its color, its texture, and the way it moves to copy more than a dozen different sea creatures with enough accuracy to fool the things that live alongside them. It flattens its body and ripples along the bottom like a venomous flatfish. It tucks 6 arms away and trails 2 out behind it, striped and waving, and becomes a sea snake. It spreads its arms stiff and floats, imitating the spines of a lionfish. The list runs past 15 species, by some counts. And here's the part that lifts it out of the ordinary range of camouflage. It appears to choose. Researchers watching it have noticed it doesn't run the same disguise every time. It seems to select which animal to imitate based on what's threatening it. Bothered by a particular fish that's afraid of sea snakes, it becomes a sea snake. The mimicry isn't a reflex it falls back on. It looks like a decision, made on the spot, about which lie will work best on this specific audience. That's a different order of trick. It's not just hiding, it's reading the room. The machinery underneath is its own marvel. The octopus has no skeleton, nothing rigid anywhere in its body, which is partly why it can pour itself into shapes that no boned animal could manage, and squeeze its whole body through a gap barely wider than a coin. Its skin is wired directly to its nervous system. Packed with color cells it can fire to change shade and pattern in under a second, and tiny muscles that push the skin up into bumps and spikes and then smooth it flat again just as fast, switching texture the way it switches color. The thing that should make it helpless, having no bones at all, is exactly what lets it become a different creature on demand. But the strangest fact about the mimic octopus is about where the thinking happens. Most of its neurons aren't in its central brain. They're spread out through its arms, so much so that the 8 arms together hold more nerve cells than the brain does. The practical meaning of that is genuinely hard to picture. Each arm can, to a real degree, sense and react and adjust on its own, partly independent of the central brain. So, when this animal is doing its impossible act, body flat, 2 arms playing snake, color shifting, texture spiking, it isn't necessarily running all of it from one command center. Parts of the disguise may be handled by the limbs performing them. You're not trying to outthink one animal pretending to be another. You're trying to outthink something whose body argues it might be several minds at once, and none of them are showing you what they actually are. Superb lyrebird. The octopus lies to your eyes. The next animal lies to your ears, and it has been caught using that lie on hunters directly. There's a bird in Australia that can imitate a chainsaw, not approximate it, reproduce it, the rev and the cut, accurately enough that people in the forest have looked around for logging crews that weren't there. It's the superb lyrebird, Menura novae hollandii, and it has the most powerful vocal mimicry of any animal on Earth. It can copy, with near-digital fidelity, almost any complex sound it hears often enough. Car alarms, the mechanical click and whir of a camera shutter, including the motor drive. The calls of dozens of other bird species exactly. There are recordings that have convinced experienced birdwatchers they were hearing a whole different species, or a piece of machinery, until they spotted the lyrebird doing it. The instrument behind this is the most complex vocal organ in the bird world. Birds make sound with a structure called the syrinx, and most species have a fairly simple one. The lyrebird's is extraordinary, controlled by several pairs of independent muscles that let it shape sound with a precision nothing else can match, even producing more than one frequency at the same time. It's less a throat than a synthesizer made of muscle, and the bird has spent its life sampling its environment and learning to play it back. Now, why does this matter for hunting? Because the lyrebird doesn't just collect sounds for show, it weaponizes them. A common way to hunt secretive forest birds is to call them in, to imitate their sound and draw them toward you. Against a lyrebird, that approach collapses, because the lyrebird is better at the game than any caller could ever be, and it uses sound the way other animals use camouflage, to confuse and misdirect whatever's trying to find it. But the documented behavior goes further than that, and it's the part that's hard to forget. Researchers have recorded lyrebirds imitating the sound of an entire flock of other birds, a whole mob of different species, all mobbing a predator at once. A full, layered, panicked alarm. One bird producing the sound of a crowd of birds reacting to danger. The leading interpretation is that it's a deliberate deception aimed at whatever's approaching. A person, a dingo, broadcasting the audio signature of a predator has been found right here. Everything is sounding the alarm. to make the intruder believe there's danger nearby and back off. The lyrebird isn't hiding from the hunter. It's faking an emergency to send the hunter the other way. It builds a threat out of pure sound and lets the hunter's own caution do the rest. Hammer leopard. The octopus and the lyrebird win by deception, by being something they're not. The last animal on this list wins by the oldest method there is, taken to an extreme that makes all the cleverness almost unnecessary. It wins by not being there. There are, by most estimates, only a little over 100 Amur leopards, Panthera pardus orientalis, left in the wild. Not 100 in some small reserve, 100 or so on Earth, scattered across the cold forests of the Russian Far East and the edge of northern China. It is the rarest big cat on the planet, and that rarity is the first wall. The odds of crossing paths with one in thousands of square miles of temperate forest are so low that researchers have compared the chance of tracking one down to winning a lottery. You can spend a career in its range and never see one. Many people who live inside its territory their entire lives never knowingly do. And that's not only because there are so few. It's because of how the Amur leopard behaves. This is an apex predator, a large, powerful cat at the top of its food chain, and yet it moves through the world with the nervous, vanishing caution of a small prey animal. The moment it catches any trace of human scent, it doesn't investigate and it doesn't stand its ground. It withdraws quietly, completely. It can live in the forests bordering villages, close to people, for years, and the people nearby may never once register that it's there. An animal that could, in theory, be a danger spends all its effort making sure it's never seen by the one species it's learned to treat as the real threat. The body backs up the behavior. Its coat changes with the seasons, a short, pale, creamy yellow in summer, and then in winter, a dense pale coat that can grow a few inches long, shifting how light catches it, so the cat blends into dry grass and bare branches in the warm months and into snow and frost in the cold ones. 2 disguises a year, swapped out as the forest changes color around it. It doesn't just hide. It recamouflages on a seasonal schedule. But the detail that captures what this animal really is comes from the scientists who tried to follow it with satellite collars. Tracking the cats by signal, they found something about how the Amur leopard moves across the forest floor in winter. The floor is covered in dry, frozen leaves and brittle ground cover. The kind of surface that crunches and snaps under any weight, the sound that gives every other animal away. The Amur leopard appears to have solved even that. Researchers describe it shifting the way it carries its mass as it steps, redistributing its weight toward the inner part of its paws, placing each foot so carefully that the snap of frozen vegetation under it drops to almost nothing. By some descriptions, close to zero. So the rarest cat in the world, in the one season when the entire forest is wired to betray any creature crossing it, walks across the trap and barely makes a sound,